Prior to a fire, there was a spark. Prior to a tree, there was a seed. Prior to a planet, there was dust. So prior to the universe, surely there must have been something. Didn't there? But this question is far stranger than it seems. The Big Bang was not an explosion of matter into empty space, like a bomb going off in a room. It was the rapid expansion of space itself. And possibly, it was also the beginning of time. Today, the universe is expanding. Galaxies are moving away from one another, and the farther away a galaxy is, the faster it appears to recede. This does not mean Earth is at the center of the universe. It means space itself is stretching. A useful image is a balloon with dots drawn on its surface. As the balloon expands, every dot moves away from every other dot. None of the dots is the center of the expansion on the surface. The universe may behave in a similar way. If we run this expansion backward, galaxies move closer together. The universe becomes smaller, hotter, and denser. Go back far enough, and the observable universe was once compressed into an extremely hot, dense state. That is what we call the Big Bang. But the name can be misleading. It was not matter exploding into space. It was space itself expanding, filled with energy, particles, and radiation. About 13.8 billion years ago, the universe began expanding from this hot, dense state. At first, there were no stars, no planets, no atoms, no Earth, and no life. The early universe was like an ocean of pure energy. As it expanded, it cooled. Tiny particles formed. Later came protons and neutrons, then simple atomic nuclei. Much later, electrons joined with nuclei to form the first atoms. After hundreds of millions of years, the first stars ignited. Inside those stars, heavier elements were created: carbon, oxygen, iron, the ingredients of planets, oceans, rocks, and living things. In that sense, everything we know began with the Big Bang. But what came before it? This is where science becomes strange. In everyday life, before always makes sense. There is a before breakfast, a before sunrise, a before birth. But time may not work that way at the beginning of the universe. If time itself began with the Big Bang, then asking what happened before, it may be like asking what is north of the North Pole. The question feels natural, but it may not have a normal answer. At the North Pole, every direction points south. There is no place farther north. In the same way, if time began with the Big Bang, there may be no earlier moment to point to, no yesterday, no empty darkness waiting, no clock ticking before the universe, just the beginning of time itself. But not all scientists think the Big Bang was the absolute beginning. One idea is the Big Bounce. According to this possibility, the universe may go through cycles: expansion, contraction, extreme density, and then expansion again. In this picture, the Big Bang was not the first moment of everything. It was a bounce from a previous universe. Another idea comes from cosmic inflation. Inflation suggests that in the first tiny fraction of a second, the universe expanded incredibly fast. Some versions of this theory suggest inflation may never fully stop. New universes could constantly form inside a larger cosmic background. This is called eternal inflation. If true, our universe might be just one bubble in a vast multiverse, with its own space, time, and laws of physics. There is also the possibility that the universe emerged from a quantum state. In quantum physics, empty space is not truly empty. It can contain fields, fluctuations, and energy. Some scientists suggest the universe may have arisen from such a quantum fluctuation, but this does not mean it came from nothing in the simple sense. A quantum vacuum is not empty darkness. It is a physical state with rules and structure. Another possibility is that our universe is part of a higher dimensional reality. In some theories, the Big Bang may have been caused by cosmic structures colliding in dimensions we cannot see. These ideas are fascinating, but there is a major problem. We do not know which, if any, is true. The Big Bang theory itself is strongly supported by evidence. We can see that the universe is expanding. We can detect the cosmic microwave background, the ancient afterglow of the early universe. We can measure the abundance of light elements, such as hydrogen and helium, which matches predictions. But what happened before the Big Bang is much harder to test. As we look farther back, the universe becomes hotter and denser until our current physics breaks down. To understand the first moment, or anything before it, scientists need a theory that connects gravity with quantum physics. We do not have a complete one yet. So the honest answer is, we do not know what existed prior to the Big Bang. Maybe there was no before. Maybe time began with the universe. Maybe our universe came from a previous one. Maybe it is one bubble in a multiverse. Maybe it emerged from a quantum state. Or maybe the truth is stranger than anything we can imagine. The Big Bang is not just a story about the past. It is the edge of our knowledge, where space, time, physics, and existence become uncertain. Everything we see today, stars, planets, oceans, mountains, animals, and humans, came from an early universe hotter than any star. And before that, perhaps another universe, perhaps no time at all, perhaps something we do not yet have words for. The universe began with a mystery, and every time we look deeper into space, we are also looking deeper into that mystery.